When I was in university, I had this very specific, very romantic image of what my life as a software developer was actually going to look like.
Ooh, let me guess. Standing in front of a massive glass whiteboard.
Exactly. A glass whiteboard, maybe a latte in one hand, drawing these beautiful, clean boxes, designing the architecture. It felt very noble, very intellectual.
Like you were building a cathedral of logic.
Right. But then reality hits you.
Reality hits hard.
Yeah, because if you've actually tried to ship code recently, especially in a complex environment, you realize you aren't an architect at all. You feel a lot less like someone designing a cathedral and a lot more like a plumber.
A plumber.
Yeah, a plumber. You're not soaring in the clouds. You're under the sink. You've got a wrench in one hand. You're covered in digital grease, and you're just desperately trying to figure out why the hot water pipe won't fit into the cold water valve without spraying water all over the kitchen floor.
That is a painfully accurate analogy for modern development. We spend so much time just gluing tools together. We aren't writing algorithms most of the days. We're fixing leaks between dependencies.
Exactly. And that gritty, messy reality is the theme of today's deep dive. We are looking at a really interesting technical struggle from a blog post titled Notes on Python Programming by a developer named Ang. And I love this on his site. He explicitly refers to himself as an old software plumber.
That is a fantastic title. It implies experience, sure, but also a kind of resilience. It suggests he's seen some leaks in his day and lived to tell the tale.
He definitely has. So specifically, we're looking at his post from February 24th, 2026, The Conflict. It's a classic tool showdown. In the blue corner, we have Nox, the trusty automation tool for testing. And in the red corner, we have Ove, the incredibly fast, modern Python version manager.
Both are excellent tools. In fact, they're probably two of the most popular tools in the Python ecosystem right now for you to use.
Right. But apparently, when you try to make them talk to each other, leakage, serious plumbing issues. So our mission today is to trace Ang's journey. We're going to see how he went from a broken build to a complex custom fix to a cleaner interface. And then, and this is my favorite part, arrive at a surprising realization about artificial intelligence.
And how it might actually be making us worse plumbers.
Exactly.
Yes.
It really is a journey. So let's set the scene. Ang is doing some digital home improvement. He is migrating his workflow. He's moving from PM, which has been the standard for managing Python versions for years, over to MVim. For the listeners who might not be deep in the Python weeds, why would someone make that switch? I mean, is PM broken?
Not broken, no, just aging. Think of PM like a reliable family sedan. It gets you there. It compiles Python from source, which is great, but it can be slow. It takes time.
And yeah.
UV is the new sports car. It's built in Rust, which is a language known for safety and incredible speed. UV installs Python versions almost instantly. It manages dependencies with surgical precision. It's part of this new wave of tooling that basically says, hey, let's stop waiting around for things to install.
Okay, so he buys the sports car. He's got Ove installed. But he still has work to do. He uses Nox to run his tests. For those who don't know, Nox is basically a checklist manager, right?
That's a good way to put it. Nox is an automation tool. Its job is to say, okay, you wrote this code. Does it work on Python 3.10? What about 3.1? What about the upcoming 3.1? It creates virtual environments, little isolated sandboxes for each version, and runs your tests.
So in theory, this should be a simple handshake. UV installs the Python versions, Nox runs the tests on them, they high-five, and we go to lunch.
In a perfect world, yes. But usually, Nox is pretty simple-minded. It looks at your system's environment path.
The path is basically the address book of your computer.
Exactly. Knocks on the front door of your system and asks, hey, is Python home? I need to run some tests. And usually Python is sitting right there in the living room, easy to find.
But not this time.
No. And this is the core conflict of our story. When Ang tried to run Nox with Of, Nox couldn't find the Python binary. It was like Of had kidnapped it.
Why? I mean, is Of trying to be difficult?
It's trying to be safe. UV prioritizes isolation. When it downloads a version of Python, say Python 3.14, it doesn't just dump it in the main system folder where anything could accidentally mess with it.
Yeah.
Puts it in a very specific isolated directory, ideally a vault.
A vault. I like that. Ang actually lists the path in the blog post, and I have to read it because it is comical how long it is.
Oh, it's a mouthful.
It looks something like /home/foobar/.local/share/cypython-3.14.0-linux-by86_64-news/bin/python 3.14.
Yeah. Try typing that 3 times fast.
So Nox is knocking on the front door looking for Python. But U has tucked Python away in the attic, inside a locked chest, behind a false wall, in a subdirectory called .local share.
That's a great visualization. Because these paths are non-standard and unique to how Web operates, Knox is essentially blind to them. It looks in the standard path, sees nothing, and the build fails.
This is that plumbing moment we talked about. You have two pipes, Knox and Uve, that are perfectly good pipes on their own, but the connectors don't match. So what does a software plumber do?
He grabs the wrench, or in this case, he writes a Python function.
Let's unpack the first solution Aang comes up with. He decides he needs to manually tell Knox exactly where of is hiding these Python versions. He writes a custom helper function called _getOfPython.
This is a classic glue code solution. The logic is actually quite interesting. It's a small function, but it does a lot of heavy lifting to bridge that gap. It takes a version string as input, like 3.n, and returns that long, complicated path we just talked about.
How does it find it, though? Does he hardcode the path? Because if he just typed out that long string, it would break the moment he moved to a different computer, right?
Exactly. Hard coding is a cardinal sin in plumbing. Never glue the pipe permanently if you can avoid it. You need flexibility. So instead, he asks of itself.
Oh, smart.
Yeah. First, the function checks if uvev is even installed using a tool called shootil.dot, which is basically asking the system, do you even know what of is?
And if the answer is no?
It just returns the original version string, like 3.n. This is a really important safety net.
Ah, the fallback.
Right. It means if someone else clones this project, say a coworker who is still driving the sedan and using PM, the code tries to degrade gracefully, it relies on a try except block so Knox can just handle it the old-fashioned way.
That is very considerate coding. Okay, but assuming of is there, what happens next?
It runs a subprocess command. Specifically, it runs UV-Python find and then the version. It's literally running a command line instruction from inside the Python script to ask of, hey, where did you put Python 3.9? UV spits back that long path, and the function hands that path over to Knox.
That seems really logical. It's dynamic. It asks the tool for the information. He implements this function. He puts it at the very top of his configuration file before any sessions are called, and he updates his Knox jobs to use it.
Right. So instead of just saying Python equals 3.n, he says Python equals underscore getaye Python 3.n.
And it works. The plumbing is fixed. The code is flowing.
It works functionally. The tests run. The red error message turns green. But, and there's always a but in these stories, fixing the leak created a smell.
It's a smell.
A visual smell. This is where we get into developer ergonomics. The code works, but using it became annoying.
Right, the unintended consequence. Aang describes what happened to his terminal output. Normally, when you run Knox, you see nice, clean identifiers for your tests, like test-3.9, test-3.11. It tells you exactly what's happening.
Clean logs are crucial. When a build fails, you want to glance at the screen and know immediately, okay, Python 3.12 failed. You don't want to parse a wall of text. Cognitive load is a real thing when you're debugging.
But because he was now feeding Knox these absolute file paths, the names of the sessions changed.
They exploded, effectively.
Yeah. Aang shares what the log looked like. He had set up a test session for multiple Python versions, 3.0 through 3.14. Instead of test-3.10, the output was test-home/foobar/.local/share/of and so on.
And imagine that repeated for every single version. Your terminal is just flooded with massive directory paths. You lose that quick visual scannability.
It's the digital equivalent of labeling your kitchen spices, not salt and pepper, but listing the full chemical composition and the address of the factory where they were packaged.
Precisely. You just want to season your food, not read a manifest.
Mm.
So Aang realized that while the plumbing held, the user experience was degraded.
So back to the drawing board. He needs a way to use the UV paths but keep the clean names. This leads us to the refinement.
This is a clever workaround. In his first attempt, he passed a list of these complex paths to a single Knox session. Knox looked at the list and said, okay, I'll name the sessions based on the inputs. Since the inputs were long paths, the names became long paths.
Makes sense. Knox was just doing what was told.
Exactly. So Aang flipped the script. Instead of one session with a list, he switched to a Python for loop inside the config file.
A loop inside the configuration file.
Yes. Remember, Knox configuration files are just Python files. You can do anything you can do on Python. So he iterates through the list of versions 3.10, 3.11, 3.1, 3.13, 3.14. Inside the loop, he creates a separate Knox session for each iteration.
Why does that help with the naming? It sounds like more code.
It is more code, but it gives him control, because Knox allows you to explicitly set a name parameter when you define a session. So inside the loop, he uses a formatted string to set the name to test dash whatever the version is. He forces the name to be test dash 3.10 regardless of what the underlying path is.
Ah, I see. So he's explicitly overriding the label. He's saying, I don't care that the path is 40 characters long. We are calling this test dash 3.0.
Exactly. He decoupled the label from the value. It's a classic UI trick. Hide the ugly machinery behind a nice, clean button.
And the result?
The logs went back to being clean and readable. Test dash 3.0, test dash 3.11. Developer happiness is restored.
Okay, so at this point in the deep dive, I'm feeling pretty good. We had a problem, we used a helper function, we had a UX issue, we used a loop to fix it. It feels like a complete success story.
It does. It follows the perfect narrative arc. Problem, struggle, solution, refinement.
But there is a twist, and honestly, this twist is why we picked this specific blog post.
It's a great twist.
After explaining all of this, the helper function, the subprocess call, the loop, the naming trick, Aang drops a bomb at the end of the post. He reveals that after all that work, he does not recommend this approach.
It's the anti-recommendation.
Yeah.
I love it.
He went through all that trouble to document it, only to tell us there is a better way coming in a future post, and this specific code is a lesson in what not to do.
And the reason why he went down this rabbit hole is the real story here.
Right. He reveals that this complex solution, the helper function, the looping, was likely influenced by AI-generated suggestions.
It's a fascinating insight. We've all been there recently. You ask an AI coding assistant, how do I make Nox work with UV? And the AI is very eager to help. It generates code that is syntactically correct. It runs. It solves the immediate error.
But it's a hallucination, or at least over-engineered.
Right, it lacks context. It lacks the understanding of, is this the simplest way? The AI hallucinated a complexity that wasn't strictly necessary. It sent Aang on a detour of writing custom plumbing functions when, as he hints, there's a more straightforward method documented somewhere that does this natively.
It's the difference between building a bridge and just walking around the stream. The AI loves to build bridges because it has seen a million blueprints for bridges.
Exactly. AI models are trained on vast amounts of code, including complex workarounds people wrote years ago for other tools. So when it sees a path not found error, it defaults to, here is the Python code solve X, rather than, here is the setting that toggles X.
And Eng's conclusion is really powerful. I want to quote him directly here. He says, manually going through search results and documentation one by one yields a much better outcome.
That is a call to return to basics. It's a reminder that reading the manual is still a superpower. We are getting so used to the instant gratification of an AI snippet that we're forgetting the value of understanding the tool's documentation deeply.
It's efficient laziness versus effective understanding. The AI gave him a working solution, but it was messy and required that secondary loop fix to make it readable. The optimal solution was likely hiding in the documentation all along.
And that's the danger of the software plumber mindset if you're not careful. You can get so focused on fixing the leak right now with whatever tape you have that you miss the fact that there was a valve you could have just turned off.
Speaking of the software plumber mindset, I think we need to take a minute to appreciate the author, Aang, because digging into his profile gives this whole story so much more flavor.
Oh, absolutely. The sidebar and footer of his blog, canming.org, is a rabbit hole in itself.
He's not just a Python dev. This guy is a true tinkerer. I was looking at his notes sections.
The sheer variety is staggering.
He has notes on gardening, and get this, there are over 800 parts.
800. That is dedication. That is not a hobby. That is a discipline.
He writes about red pineapple, dwarf powder puffs, and then notes on fish keeping. He's got logs for guppies, discus, and spotted knifefish.
That's a serious fish keeper. Spotted knifefish are cool, but they are sensitive. You have to really pay attention to the water quality.
He also writes about photography, dieting. He even has a post about troubleshooting a leaky tank.
Which connects perfectly to the software plumber identity.
That's what I thought. Whether he is figuring out why his fish tank is leaking or why Nox can't find the UV path, it's the exact same part of the brain.
It's the diagnostic mindset. Observation, hypothesis, test, refine, fixing things yourself.
And patience. You don't write 800 posts about gardening without patience.
And that patience is exactly what he advocates for in the coding post. The patience to ignore the quick AI fix and actually read the documentation. It's the same trait that makes you good at gardening. You can't force a plant to grow, and you can't force a tool to work against its nature. You have to understand it.
I love that connection. It makes the technical advice feel so much more grounded. This isn't just some tech influencer trying to sell a course. This is a guy who has spent years debugging life, from his aquarium to his server.
And he's sharing his failures, or at least his suboptimal paths, which is something we don't see enough of. Usually people only post the final perfect code. Ang posted the messy journey and said, hey, look, I got tricked by the AI. Learn from my mistake.
So let's synthesize what we've learned today. We started with a broken path, integrating Knox and Evie.
We learned that Evie uses unique, isolated paths to keep things safe, which breaks Knox's standard discovery methods.
We looked at the AI-inspired solution, building a custom tool to fix it using a helper function and subprocesses.
And then we refined the output for readability using a manual loop to override the naming.
Only to hit the twist that this entire thing might have been an AI-induced detour, an over-engineered hallucination.
Which brings us to the final takeaway. In an era where AI coding assistants are everywhere, the importance of skepticism is huge.
Right. Just because the code works doesn't mean it's the right way to do it.
Precisely. Technical debt often starts with a working solution that was just a bit too complex for its own good.
So I want to leave you with a provocative thought to mull over. Think about your own work. How often do you accept a complex answer from an automated tool when a simpler answer might be hiding right there in the documentation?
It's a great question to ask yourself.
How much AI plumbing is cluttering up your code base right now, just waiting to burst?
A scary thought, but a necessary one.
It is. Huge thanks to Ang, the old software plumber, for documenting his journey. We will definitely be keeping an eye out for his follow-up post. Until then, keep plumbing, keep deep diving, and thanks for listening.
Goodbye, everyone.